welcome to our first episode in 2023, episode 125 of our SAP on Azure video podcast. Today is January 5th, and together with Robert and Goran, we are here to talk about anything related to SAP and Microsoft. Hello, everyone. So, security needs to be top of mind. One of our last episodes, actually, in the last year, was already on SAP and security. At that time already, we mentioned that over the holidays, typically a lot of attackers are very, very active. And unfortunately, that was again true this year. So I read a lot of different reports of attacks, of password hacks that happened, ransomware attacks, and actually also a shortage of security experts in a lot of companies. So today we want to kick off the new year with Evren Buyruk, who will talk about security optimized deployments with SAP on Azure. But before we hand over to him, like always, following our tradition, we quickly want to take a look at some of the news from this week, or actually the last few weeks. And I want to start with a personal blog post, basically, that I published on a look back on 2022 from an SAP and Microsoft perspective. And you might remember we had last year our final episode with Jürgen Thomas, where we talked about a lot of things that happened in 2022, and that actually got me excited to write this down as well. So I blogged this here on the SAP community page, and there's really so much that happened. So if you can spend a few minutes, read through this, I really think we accomplished quite a lot in 2023, and yeah, we will have a lot of fantastic things planned for 2023, I would say. So with this, another thing that we had already actually mentioned in one of our last podcasts, when we had Karthik on the show to talk about Azure Backup for SAP HANA. Now there are some updates on general availability for Azure Backup for SAP HANA. So there's long-term retention, partial restores files. Then also this seamless integration with native clients and other tools is something that Karthik also had talked about already. So a lot of things are again or continues to happen, and I think that that's really one of the really cool things with SAP on Azure, that there's constantly new stuff happening there. So speaking of one of the topics for today, there was an article in German actually by the Handelsblatt that talked about that the experts on security are getting very, very scarce, and that's really what we are seeing. This article unfortunately is only in German, but if you read through this, or if you use Bing Translate or something else to translate it to English, they really outline that the whole quality of attacks have changed quite dramatically. First of all, there are a lot of tool sets, there are a lot of services almost that you can buy to attack a customer system. And that actually combined with this notion that the security experts are very scarce, and in a lot of cases, security is not the core of your business. I mean, if you are in manufacturing, if you are in a pharma industry or something like that, then your core business is pharma, analytics, or something like, not necessarily security. And that's actually why I really, really love this the topics that Evren will talk about, because Azure is here to help you with these services, to help you, to empower you to make your SAP systems more secure. So again, I think, yeah, the period over the year again showed very much how critical it is to really protect your SAP system, or not only obviously your SAP system, but your whole IT environment. And yeah, in a few minutes we'll hear some cool stuff from Evren, how Microsoft can help you make your environment more secure. Then there was another blog post by Boris Gebhardt on ABAP Cloud. So if you have followed this, ABAP Cloud, or steampunk, that was introduced a few years almost ago already, is an evolution basically of the whole ABAP development concept. And in this blog post, Boris outlines the step, well, what exactly is ABAP Cloud? And he highlights the different flavors actually here where you can use ABAP Cloud. So obviously it is available in the ABAP environment. So the original steampunk that was available, it is then also available in this public cloud edition and in private edition, and on S4 or SAP S4HANA on premises, which I think is also really, really interesting. So now if you have a new S4HANA on-premise system, and for whatever reason you cannot use the S4HANA public cloud edition, you want to stay to run your own SAP system, preferably on Azure, obviously, then you can still now leverage and benefit from ABAP Cloud, from the whole programming model, from the new evolutions that happened in ABAP Cloud, now also in your on-premise environment. And Boris outlines in this blog post everything about that. One other topic is SAP Business One, and I have to say I'm not an expert on SAP Business One. Actually, I've never really worked on an SAP Business One system, but I know there are thousands of customers out there that are using SAP Business One. And in this article here, actually, this is written by, let me see if I find the name. Maybe at the, here, yeah, Moshe Nachman. He outlines how you can use SAP Business One and use eventing functionalities to send events, to Azure basically. And obviously there's one way to do this via SAP, the Business Technology Platform, using SAP Event Mesh. But I think there's one sentence that I really liked. So the purpose here is not to knock down SAP BTP, which rightfully earned its place, but merely to state that BTP is not the only game in town. And I think that's always also what I'm preaching. I really love BTP functionalities, but there are some scenarios where you can enhance BTP. And one of the scenarios that is outlined here is how you can connect SAP Business One directly to Azure Event Grid, and from there have the events then obviously processed in the Microsoft world. One last thing before we hand over to Evren, there was a very interesting YouTube video on modernizing apps or scenarios, and especially mainframe scenarios with the Power App. Or with the Power Platform in general. And I thought that was also really interesting because obviously there are still a lot of customers out there that are using mainframes. And in a lot of cases, there's nothing that you can do. Now, with the Power Platform, you can actually create APIs for these mainframe applications. And with this exposure of APIs, then all of a sudden it's much, much easier to create apps that access or that also interact with your mainframe applications. So April Dunham and Jim Duggan outlined, it's actually a nice video that really guides you through these steps and talks about the benefits, and then they actually show you a small Power App that can interact with your mainframe application. So if you have a mainframe application, if you want to modernize it, then I think looking at this video can definitely be beneficial. So with this, that was all from me for this week. With this, let's hand over to Evren. Evren, you have been on the show several times. Maybe still for those of you, for those of our viewers or listeners that have not yet seen you, maybe you can quickly introduce yourself, and then I'm really looking forward to your presentation.
So thank you so much, Holger. I'm so happy to be here actually. And then this is a privilege because I see that you ended the year with Jürgen Thomas in 2022. So you're starting new year with me, and I feel like I'm privileged right now. Hola, Jürgen. Okay. Hi, everyone. My name is Evren Buyruk. I am an SAP I'm actually, security architect and networking architect. I used to cover SAP. Now I cover SAP and non-SAP. Basically, I am focusing on anything that actually just runs on Azure from security, networking, integration point of view. And I actually just go deeper dive into the elements and functions of each and every security component to help our customers leverage best-in-class security tools and technologies to leverage on Azure. So myself, I'm a certified cloud solution architect, and I'm certified across the Microsoft entire security portfolio and also networking DevOps portfolios, and I'm a security, and I'm also a network architect from Microsoft side. So, and I'm so very happy to be here in this presentation today. That Holger actually this is the fourth time actually that I am here on this session. So I'm really very privileged actually to be here on this presentation. So what
Evren,
I'll cover
before you continue, since you mentioned certifications, that is something that is always just amazing to me. How many certifications do you have in the meantime?
I think that I have now 40, around 40 with external, and I have 45, certifications. But the learning is the key is that once a person is actually spending a lot of time on the technologies, and then you get familiar with what is going on, and then it actually just becomes very easy. So for those who would like to be certified on Microsoft solutions, is all about our documentations. Just go through our documentations, and then hands-on, just create yourself a subscription and just play with the systems, technologies. And we have a lot of good technical materials that are available on Microsoft Docs and on Microsoft Documents, and they can download, they can read, they can go through each and every session one by one to actually just get to the bottom of this technology. So like, it's very easy. It's all about love. If you love it, you're going to be certified. So it's my motto.
Perfect.
So today that, I'm going to be providing the audience with the cloud-based security controls for SAP on Azure and also non-SAP on Azure, also the security tools and functions. So before I actually just go to the details, so regardless it is the customer, partners, or users, we always have to ask this question to the audience. Why are you moving to the cloud, and what do you really want to get out of cloud migration? Do you need to scale to meet demand or reach new markets? Will it reduce cost or increase business agility? So when defining the cloud business strategy, our audience should really understand that cloud economics and the key details behind it is important, as it actually just impacts the business. So then there's also the turnaround time for this investment. So when this investment is going to be emerging, and when the users and customers are going to see the benefits from it. So while we're looking at these like overall strategies, we are also just looking at the efficient security strategy and architecture, and also a good security strategy and architecture to help our customers maintain control over the applications and any resources that they actually just throw on the public cloud environment, just like Azure. So they have to know the strategies, or they have to build the strategies to maintain control over their environment, to ensure that they can actually just be staying compliant with the industry standards that they have, like the information security management and corporate or any organizational standards that they have. So while I am actually going to be speaking about the overall, the zero trust principles to secure any application on Azure, we have to just be mindful that it is all about the strategy the customer or the user or the partner needs to build for the security principles. So it's gonna be very important to have how many engineer teams are just going to be working on the same cloud platform, if there are going to be multiple subscriptions to manage, if there's going to be any regulatory requirements that must be enforced, like defined standards that must be followed for all the cloud resources, and also like the number of cybersecurity architects who are going to be utilizing the Microsoft Security Reference Architecture. These are all the components of the strategy, but these are limited. Of course, this is the things that are just coming off the top of the head. And then, but there are lots of other areas where a customer or user can really just build this strategy. So it's all up to them. So what we are doing, what we are responsible for on Microsoft side, upon defining the strategies that Microsoft actually just believes in, zero trust principles that really help our customers secure any application, including SAP application or non-SAP application and data. Basically, we have to look at these elements such as assuming breach, verify explicitly, using least privilege access control. Like, for example, when we're talking about verification explicitly, we have to know that we have to protect these assets against attacker control by explicitly validating that all trust and security decisions use all the relevant available information and telemetry. So once we are looking at the least privilege access, we have to know that we have to limit access of a potentially compromised asset with just in time and just enough access, which we call it JIT and JEA. These are the acronyms that you might actually just see on the Microsoft documents. And so we're also looking at the risk-based policies like adaptive access control. So these are the two components which are important, but the other one is the assuming breach. This is the main component of the zero trust security. We have to assume attackers can actually go ahead and just successfully attack anything in the Azure or in a public environment. This might be identity, this might be network, this might be device, SAP application, non-SAP application, bolt-on, infrastructure, anything. So it needs to plan accordingly. So these three components are the key takeaways of the zero trust principle. Basically, these are not going to change from customer to customer because every single customer, they have to strategize their security posture on Azure or public cloud. So they have to look at these components like assuming breach, verification explicitly, and using least privilege access control. These are three components. And then how we're going to be building the Microsoft security solutions on top. For instance, we are looking at different solution areas like identity access management, application data security, network security, threat protection, security management. Our customers really need to manage multiple security categories to be able to effectively reduce their risk. Basically, they have to have different towers of identity access tower, application and data security tower, and then security management tower to be able to be compliant and defend against the threat vectors. But in the same time, like Holger mentioned, that they're really just new modern security breaches that actually just were introduced. So our customers really need to update themselves with the overall new security components or security threats that actually just emerge. So we have to know, and then we have to let our customers know what these security threats are about. So then we can talk about identity access management tools that they can actually enable to take an identity-based approach to security and establish truly conditional access policies. Then they can take the application and data security. But these are all the things that need to come after the knowledge gain. Without the knowledge, without understanding what exactly the TCP flood is, what exactly the brute force attack versus the application layer, let's say the layer 7, forcing attacks. And we have to we're gonna be careful there, because if the customer doesn't know, then there's a problem there because they don't know where to protect. So what we do from Microsoft side, we are helping our customers understand this technology. So we tell them what they should be doing, looking at, but we are not forcing them to do anything. So we can advise, we can recommend some solutions, but it's all about the customer's decision in the end. So that they have to just select Microsoft to go ahead and just proceed with the best-in-class security or any other vendor or any other cloud provider. But it is their responsibility to make sure that these components are used, leveraged, so they can actually just run their SAP and non-SAP securely, like application data security, which is going to be helping them to protect the application in this context, SAP application or non-SAP, and then their data, it might be SAP or non-SAP data. So this data is going to be moving around. It is going to be both inside and outside the organization. So we need to know that what is the access control is going to be, what exactly the a antivirus solution is going to be for the particular application that is running inside a VM. So then we're going to be looking at outside that VM, like the network security, for example. We have to establish a secure connection to and within Azure using virtual networks, so network security groups, VPNs like ExpressRoute, and then we have to protect and ensure the availability of these applications so that we can just make sure that the network is actually augmented, the application and data, which is actually just running inside that network, is going to be secure. Then the threat protection. This is the topic that is actually very important that I'm going to be speaking about some of the components like Sentinel and Azure Firewall integration, and then automation response times with the Azure Firewall. So this is to secure the entire organization from threats within Azure Sentinel, which is actually a cloud native SIEM solution, which is the security information and events management tool that customers can use it to scale to their needs. So then they can actually just access it from anywhere to actually just make sure that the threat protection is there. Then the security management is very important, as this is very important actually, as customers assess security state continuously, or they want to actually just make the assessment continuously, especially as cloud workloads change dynamically and then new workloads are coming. So Microsoft actually just brings tools like the Security Center to monitor the security state of the Azure resources and hybrid workloads, to provide dynamic security scorecard and recommendations to prove that, to improve the security in a centralized console, making security management easier across different resources that customer actually just has. So I'm just gonna go again, one by one, each and every component. So these are the common areas which I'm going to be talking about, and I'm just going to be focusing on DDoS protection, firewall, and then also the threat analysis and threat intelligence with Sentinel. But these are the components from the application protection and segmentation perspective, like why we have the DDoS protection, why we have the web application firewall, Azure Firewall, network security groups, VNet integration. What are all these components, and why do we use network security groups, for example, NSGs and VNet integration for multi-segmentation? Why do we have VNet address space, and under that VNet address space, we have a bunch of subnets which we are protecting with NSGs, quadruple rules that we are applying for inbound and outbound for, VMs between subnets, traffic control. So these are important. But again, every single customer scenario is going to be mandating different security protocols and functions and tools. So that is the reason why Microsoft has this general view, which is the DMZ, which Microsoft actually leverages for each and every customer, regardless what their security requirements are. We are giving them all the best practices that they can actually use and choose to make sure that the security is going to be number one priority for their entire landscape from deployment and implementation and run perspective. So the concept of DMZ, we have it on Azure. It is a layered network security approach to minimize the attack footprint of any application, regardless SAP or non-SAP. We are actually comprising it with either 2 layers or 3 layers of security and protection concept with additional user-defined routes and firewall rules, which I'm going to be mentioning, and I'll give some examples as well. So Azure network traffic to and from any resources in a virtual network, we're going to be using network security groups and network virtual appliances. And then when we're looking at the cloud DMZ, we're going to add more functionalities to it based on the requirements of the customer from the security point of view. So everything is going to come to the zero trust security, which is to provide our customers with a modern security framework so that they can manage the complexity of their organization. So then we are actually just opening them the door for a holistic approach to zero trust that we are recommending these customers, our customers, and our prospects to extend the zero trust security, rules and tools to actually just throughout the entire digital estate, regardless it is SAP or non-SAP. Let's go and just protect everything. Basically, we're not going to be separating SAP from other applications. We're going to treat each and every application and data that is residing in Azure the same. It's still going to be the TLS 1.2 for the transport layers socket, which is going to be the data in transit security. We're still going to be using Azure Active Directory tools and technologies to actually just modernize their IAM requirements. We're going to be using technologies like front door, traffic manager. We're still going to be looking at tools like web application firewall. We're going to be looking at Azure Firewall, third-party MVAs, which are certified to run on Azure. So basically, this slide actually just tells a lot from the overall deployment perspective, even if somebody doesn't know anything about cloud and how the cloud technologies actually just works. Microsoft simplifies it, simplifies it with the design solutions and then architectures. We make sure that our customers really understand it from very simplistic point of view. So we have the hub VNet, which is the Azure VNet, used as the hub in the hub and spoke topology. Basically, a hub is the central point of connectivity to on-premises. And then we have the spokes to actually just like communicate with each other. Though the hub VNet is typically mapped directly to an IT subscription to provide network transit, which is ExpressRoute gateway, VPN gateways, and MVAs, security and identity services. Basically, any virtual machine and workloads deployed in the hub VNet is going to be invisible to the tenant subscriptions that are mapped to the spoke VNets. This is very important as subscription protection is very important. And then when a customer is looking at, hey, where should I actually just have my virtual machines and workloads deployed? And then depending on how they want to actually just make sure that their subscription is visible or invisible, they can go ahead and just like, implement or deploy these workloads in the hub VNet. And then the subscription that is going to be mapped to the hub VNet is going to be invisible to the spoke VNets. There you go. You're actually just making sure that you are creating yourself some level of security by just like, deploying the, important components in the hub VNet, and then the subscription mapped to it is not going to be visible anybody outside that, VNet. So spoke VNets, one or more Azure VNets that are used as spokes in the hub and spoke topology. And then spokes VNets are really just focused on tenant workloads. Basically, these spokes VNets could be representation of different application states, application stacks, like it might be departments or any lines of business. So it actually just like gives a lot of answer to even like security questions on Azure, for example, about the use of the spokes versus the hub, and then where to have the subscription to make sure that it is invisible to outside world or even in the same organization. That's going to be the hub VNet. So basically, if you're mapping it to the hub VNet, and then you're gonna have the governance on that subscription, and thus that subscription is not gonna be visible to the spoke VNets, which are just going to be hosting the tenants. This is important. So then we are looking at the RBAC, and then these are the role-based access controls that we are applying them to, like to the environment. For example, it is common for IT and security professionals to be granted role-based access control RBAC to the spokes to maintain infrastructure components such as VNets. Basically, if you want to have people to actually just make sure that from the infra side to provide pure maintenance on the systems, and then you can actually just like assign company resources to the spokes, and then these people can actually just have the infrastructure level like control mechanism on the overall like subscription. Basically, we are looking at, when we are actually just looking at the RBACs, and then we are assigning them in the for the users in the spokes, so they can they can provide the maintenance or like maintenance, infrastructure maintenance, or any component on that matter. They can actually just like have these roles. Basically, you can define network security groups. You can do the route tables, and then so forth, and then you can actually just like complicate it if you want to make sure that some of the tools and technologies are not available to certain users. So we have the VNet peering, which is something that is very important. Is actually non-transitive low latency connection between two VNets. Basically, once we peer it, the VNets exchange the traffic by using the Azure backbone, which is the Azure TLS, actually, transport layer socket. Once you have the VNet peering enabled, then there's nothing really just to worry about much, because transport layer socket is going to be actually just like enabled 100 times, 100% of the time. And then this is going to be, I actually just said 100 times, but 100% of the time, it is going to be enabling the security from point A to point B. So in a hub and spoke network topology, we are using the VNet peering to connect these hubs to each spoke. This is giving the answer to how we are actually just enabling this connectivity to the spokes. There you go. The VNet peering is actually just like making sure that you are establishing that connection. So you can peer virtual networks in the same region or different regions. So you can also configure spokes to use the hub VNet's ExpressRoute or even Azure VPN gateway to communicate with the on-premises network. So when an ExpressRoute circuit is connected into this hub and spoke design, then the BGPs are actually just like, becoming important, because the BGP routes are advertised from the on-premises into the ExpressRoute virtual gateway, will not natively transit into the spoke VNets. This is another security rule. I am just like, this is, sometimes I'm hearing it from customers, hey, when you have ExpressRoute circuit connected to, what exactly it does to my environment? Mr. Customer, when you have the ExpressRoute circuit is connected into the hub and spoke design, the BGP routes, which are advertised from the on-premises into the ExpressRoute virtual gateway that you're enabling, is not going to transit into the spoke VNets. You are just going to be controlling that mechanism. Instead, what's going to happen? They ask me, what's going to happen? These routes will populate in the hub VNet only. Likewise, the ExpressRoute gateway will not natively advertise spoke VNet routes out either. You won't be able to actually just do that. Instead, it will only advertise the network ranges that belong to the hub VNet. Basically, in order to allow the ExpressRoute virtual gateway to advertise routes from the hub to spoke, then customer really needs to go to the portal. They have to allow the gateway transit, and then they have to use that option in the VNet peering panel of the hub. I'm saying it should be in the panel of the hub, not the spoke. So basically, the control mechanism on the hub is going to be actually just dispersing across spoke. There you go, another multi-segmentation. So Holger, as you see that, like when I'm talking about this, I am actually just finding, hey, what are all the things the customer can do to enable security, right? There are lots of things to do, but ExpressRoute circuit is not only given the dedicated route to Azure, but also just like, gives you the BGP routes populated in the hub, so you can actually just like, manipulate accordingly. Even from spokes to on-premises, it is not going to be easy. You're still going to be able to actually just like, collect it in the hub. So gateway last resort. So my colleague, Herman Opperman, actually has been speaking to me about this a lot. And he actually just mentioned about Azure Firewall. Just use Azure Firewall for gateway last resort instead of just using anything else, like even the standard load balancer. Why? You can do the egress control mechanism very well using Azure Firewall. And then if you want to go and just like, kill the, site-to-site VPN connectivity, for example, and then you can use the NAT on the gateway, NAT gateway. I'm going to be speaking about this. I'm excited about these topics. So VNet peering, I'm also checking the time. I'm actually just like, looking at, like, I also have a very good demo to run.
Yes.
To show. So I'm just going to fast forward a little bit. So the VNet peering, I spoke about this, is important, is it is all about like connectivity, to be honest with you. Customer goes to Azure, they create a storage account, and then what happens? So you have to go and just create your networking. VNet peering is going to be all these VNets that you create are going to talk to each other. How? Via VNet. And is a non-transitive, it is very low latency connection between minimum of 2 VNets. So basically you have to have more than one VNet to actually create VNet peering, so it actually just peer. So once it is peered, the VNets exchange the traffic by using the Azure backbone. As I mentioned, basically you're not going to need to have a router. So in a hub and spoke network topology, like I mentioned before, you're using the VNet peering to connect the hub to each spoke, so you can peer virtual networks in the same region and again outside the region. So this actually is giving a lot of peace of mind to the customers, because network traffic between peered virtual network is always private. So this is number one. When a customer is asking, hey, is it public? No, it is not public at all. It is your connectivity. It is private to you. Traffic between these virtual networks is kept on the Microsoft backbone network, but it's not open to public. You define it. So there's not going to be public internet, like gateways or encryption is required in the communication between these virtual networks once you create it. So then you're actually, finding a solution to a lot of overhead on the, encryption, for example, because the connectivity on the on-premises systems, you have to encrypt it. On Azure, you don't even need to do that. You don't even need to use a router. And then there's no latency at all. Like one best practice that I can actually just say, if you have an SAP workload, prod workload, create yourself a VNet address space, a large one, just create a bunch of subnets underneath the same VNet address space. It is going to be actually just enabling you a lot of efficiency in terms of the latency in between VM protocols and VM NIC communication. This is like a, nobody heard this. I am just giving. So basically, I mean, if anybody wants to actually just ask, they can reach out to you, so we can actually have a, email correspondence or something. That's a rule of thumb. Just create one VNet address space, and then or for production workloads that are going to communicate each other, just like do it under the same VNet address space. Don't create different VNet address space. Don't create different, subnets under different VNets for the same production workload. Just one VNet address space like this, and then just create a bunch of subnets and your database subnet, your app subnet, and then you go from there. So if you want to resize the address space of the Azure virtual networks that are peered without incurring any downtime on the currently peered address space, you can enable that to increase the efficiency. So this is very useful, because when you need to resize the virtual, network's address space after scaling the workloads, it actually just becomes very important, because after resizing the address space, all that is required is just like, for peers to be synced with the new address space changes. Basically, this was actually a problem before. You couldn't do the resizing. Now you can do the resizing. It is actually good news is that it is not only for IPv4, Volgar, it is all now for IPv6 as well. So you can resize it. No more problems on that part. Let's say that you would like to resize the VNet that are peered, and you like to see no downtime on the existing space. Like, I'll give you an example. You can modify the address range prefix on the existing address range. For example, like let's say that you're going to be changing from 10.1.0.0/16 to /18. So you have to just add the ranges to the virtual network and delete the address ranges from the virtual network before go from there. That's that easy.
Cool.
So user-defined routes and custom routes is important topic. So basically, customers can create custom routes in the VNets to override Azure default system routes. Is very important topic, especially for customers who are part of the networking and security. They want to actually just like come to the bottom of this, what exactly it is. So if they can actually just like, add additional routes to the subnets route table. So in Azure, customers can create route table, then associate that route table to one or more virtual network subnets that are created. This is actually the reason why I said create one VNet address space, and then underneath the same address space, create a bunch of subnets. So then UDRs are going to allow you to route the traffic to the virtual appliances, which are MVAs, VPN gateways, internet, or whatever that you want to do. But the less complexity is going to be one VNet address space, and then underneath that address space, create subnets out of that VNet address space. Then once you're doing the UDRs, you're not going to worry about the latency that much. This is going to be resolving a lot of overhead. Overhead in sense of complexity, expenses, and also the latency overall impact in the business. So quad zero, which is actually, I like this word, quad zero, 0, 0, 0, 0. What exactly it is protecting the customer's environment and add some value to it. It is the quad zero, it is the UDR default route. Basically, clients running in the subnet trying to access the internet are forced to the MVA for for treatment allow or drop or log, or routing to the other new subnets built in the environment, but not yet defining the UDR route tables. They will still get routed to the firewall if they want to. Basically, you can actually just create complexities about who's going to reach out to what, who's going to actually have access. So this is going to be overriding the RBACs, and then you're going to be defining it accordingly to create more complexity. Why? Brute force attacks are always just going to come and try to affect your backend applications from running. So the more you're thinking like a attacker, the more you're actually just going to be. This is one of the great reasons why when I was doing the ethical hacking courses, you actually can learn how to think like an attacker. So then when you're actually sitting on the Microsoft side, you're called ethical hacker. Once you are not, once you're attacking, I'm going to be actually a hacker for just 10 minutes to show you how I actually can go in and attack the system. I'm still going to be using Microsoft system for demo purposes. I'm not going to go to jail. So UDR routes, these are searched and, searched before the BGP. They're like, none. So like, there's nothing to actually just like, consider from that perspective, because the UDR default route has, like, while it is having advantages, it has some disadvantages as well to actually just like, mention. Because why? It is going to force even VM to VM traffic within the same subnet out to the MVA and back. So this is going to create undesired for latency and unnecessary for like most security protection. If you are creating it under a different VNet address space, if you're inside the same or under the same address space, then you're not going to be worrying about it that much. And then once you're creating it, once it is created, Azure is creating the default route to the quad 0 address prefix with the internet next hop type. So if you don't override this route, then what happens is Azure is always going to route all the traffic destined the address prefix of any other route to the internet. There's no like, exclusion on that. So basically we have to know where to use it. So like, I'm going to give some examples. This is like, this is one of the, pictures that I actually just like, did the other day. So in this example, the firewall VM has NICs, network interface cards, in 2 different subnets. So NIC1 is the untrusted and outside interface with the IP address, which you see here, 10.0.5.4.24. It needs to forward the traffic to the internet, right? So what happens is that Azure Fabric is going to know how to reach the internet. So the firewall needs a static route, like I mentioned, on the firewall itself. So you have to create it on the firewall subnet. So it needs to point quad 0 to 10.0.5.1 that you see, which is the default gateway for the subnet. So we have to remember the first IP in a subnet is reserved for the Fabric default gateway. So NIC2 that you see here is the trusted inside interface with IP address, which is 10.0.6.4/24. So if you want subnet 1 and 3 to use the firewall for outbound internet traffic, you have to set a UDR for those subnets and point it to 10.0.6.4. So then the next hop is going to be in different level 3 segment than the subnet 1 and 3. So you're going to keep MVA in an isolated subnet different from the protected subnet. There you go. This is one use of it. The second one, this is another example. In this example, the firewall VM has NICs in the 2 different subnets again. NIC1 is the untrusted outside interface with IP address. Then the Fabric is going to know how to reach, and then how you are actually just going to do the change here is that the IP address on the NIC2 is the trusted inside interface with IP address. So if you want this 1 and 3 to use the firewall for the outbound internet traffic, you have to use the set. You have to again set the UDR for those subnets and point it to this to the 6.4, which is just going to be leveraging it. So the next hop is gonna be different now 3 segments, and then the subnet 1 and 3. So it's gonna be again keeping the MVA in the isolated subnet. This is another one to actually just use. So in this example, this is the one that with the ExpressRoute, which is to provide the client with a dedicated network connectivity. So ExpressRoute is going to always require BGP for routing, and the ExpressRoute gateway is going to require a gateway subnet which resides in the customer's VNet. So it's not going to be possible to set a UDR in an Azure, with a next hop of virtual network gateway type ExpressRoute. So in this example, which is unique and different than the previous one, you won't be able to set a UDR for on-premises prefixes to next hop ExpressRoute gateway, because the VNet address space is now going to be sending it to on-premises, and the on-premises prefixes, which is 192.168.1.0, and then the 100.0/24, which is going to be injected into the Fabric this time. So what happens is, let me actually propagate it. So subnet 1 and 3 will see a next hop of the express route for all of the on-premises prefixes which are going to be exposed. So the on-premises routes are going to be injected into the fabric via the BGP. And then if the customer requirement is just like, to have all the traffic to and from on-premises to flow the firewall, then what's going to happen is that you're going to either write a custom UDR for subnet 1 and 3, which is going to match all of the on-premises prefixes, and then you have to set the next hop to 10.0.6.4, which is going to be called the firewall trusted interface. So the key here is that the UDR is going to win a tiebreak in the event of a matching BGP route here. So now all the traffic destination from on-premises sourcing from the subnet 1 and 3 will be sent to the firewall. So then the firewall is going to have the default route out its untrusted interface pointed to the fabric, which is going to know about the on-premises routes via the BGP. This is another use of the UDRs. So basically, here in this slide, I'm just going to show you a real customer scenario where a customer wants a POC, a network topology using defense in-depth functions of Azure. So here in this example that you see that the traffic between MVA, VNet, and site A is actually just like, showing okay. I mean, why didn't I use it here? So as you can see, it is okay. So basically what happens is that the traffic between DMZ private VNet and site A, which is the green arrow that you see, is not okay. So what happened is that they did a lot of tests, and then it turns out that the traffic coming from site A is hitting the MVA, one lock at MVA level with a TCP dump on the MVA. So they collect the SYN and SYN-ACK, but no more. So now maybe the audience is going to ask, what is SYN and SYN-ACK? Is actually short for synchronized. So SYN is a TCP packet which is sent to another computer requesting a connection, which can actually just be established between them. So if the SYN is received by the second machine, so what happens is that a SYN-ACK is sent back to the address which requested by that, SYN. So the traffic is then supposed to go through the firewall, but it's going to be actually failing with no locks at the Azure Firewall level. The reason why this actually was occurring is because, there wasn't a UDR set on the Azure Firewall subnet for site A. So basically, once the customer actually just like, set the UDR on the Azure Firewall subnet for site A prefix to forward the traffic through the MVA IP, so then this actually cleared the roadblock and then the traffic control and then the traffic transit. Basically, the key was here that like the UDR, which was not created on the firewall subnet, once the customer actually just created subnet, it worked and it flew, and then the traffic was no longer bottlenecked. Is another use case for the UDRs. So Azure Firewall and where to use it. And I'm just going to go a little bit fast. So basically, to understand how Azure Firewall is protecting the virtual network, we have to know that there are two characteristics to any Azure Firewall deployments. Basically, the firewall instance has a public IP address to which all inbound traffic is sent. So the firewall instance has a private IP address to which all outbound traffic is sent. This is what I mentioned about gateway last resort. We are going to be using Azure Firewall for traffic out. So for traffic instance in, this is not going to be replacing the Azure Application Gateway, because these are two different technologies and then two different use cases. So by default, the firewall is going to deny access to everything. So our customers, they have to remember that, once they're actually just looking at the deployment, their job is to configure the firewall with the conditions under which traffic is allowed through the firewall. We wouldn't know that. It is their requirement. They know that. So each condition is called a rule. Basically, each rule is going to apply one or more checks on the data. So only the traffic that is going to pass every check in the Azure Firewall rules is going to be allowed to pass through. Otherwise, it's not going to pass through. So Azure Firewall is going to use the SNAT only when the destination IP address is outside the virtual network. So if the destination IP address is from the virtual network's private IP address space, then Azure Firewall is not going to use SNAT on the traffic. So then we're going to be looking at the intrusion detection and prevention for the Azure Firewall, which we are just going to be applying to inbound spoke-to-spoke in east-west control mechanism. So it's not going to be for like, south and north. It's going to be east and west for the TLS protection and then outbound traffic as well. So east and west is going to include the traffic that is going to go from to an on-premises network is still going to come to Azure Firewall and then application gateway to actually just provide layer 3 and layer 7. So one question that I received from customers and partners around the rules. So there are 3 rules to associate with Azure Firewall. These are NAT application rules and network rules. Basically, the NAT rule is going to be translating and filtering inbound internet traffic based on the firewall's public IP address and specified, port number. Let's say, to enable a remote desktop connection to a virtual machine, you might use NAT rule to translate your firewall's public IP address and port 3389 to the private IP address of the virtual machine, because it's not by default enabled. So the application rule is going to be the filtering the traffic based on the FQDN. For example, customer might want to use an application rule to allow the outbound traffic to access an Azure, let's say a SQL database instance using FQDN server, let's say, 10.database.windows.net. I'm just like, giving an example. And then network rule, which is important. They have to filter the traffic based on one or more of the, rules. These are like the IP address, port, and port protocol. These are important. Let me actually just go fast. So then this is the hybrid hub and spoke architecture. Basically, this is the overall how we are just going to be leveraging some technology and make sure that this is going to be, secure for the customer. And one of the key element is going to be IPsec over ExpressRoute. So I'm actually, this is overall like, summary of everything that I mentioned in the previous slides. So this topic is going to be actually a little bit like drill down of the previous one, IPsec over ExpressRoute. So it is very important because we need to emphasize that ExpressRoute is going to let our customers extend their on-premises network into the Azure, cloud over a private connection with the help of a, of course, the connectivity provider. So they have to choose their ISP. So with ExpressRoute, our customers can establish connections to Microsoft Cloud services, such as Microsoft Azure, virtual machines, and Microsoft 365. So let's say that why it is important and then how they can actually just do more on that one. So IPsec over ExpressRoute is going to come because connectivity can be from any to any IP VPN network, a point-to-site, point-to-point Ethernet network, virtual cross connection through connectivity provider at co-location facility. So ExpressRoute connections, since they are not going over the public internet, this is going to allow ExpressRoute connections to offer more reliability. It's going to provide faster speeds, consistent, latencies, and higher, security than typical connections over the internet. So now, while it is providing that layer 3 connectivity between the on-premises network and Microsoft Cloud through the connectivity provider, it actually can do more because it actually has the dynamic routing between the network and Microsoft via BGPs. It also has the built-in redundancy in every peering location for high reliability, connection uptime SLAs as well. So what happens? IPsec comes in place. So what happens when we configure IPsec over ExpressRoute? So then the question, what is IPsec, right? IPsec is a group of protocols that we are using all together to set up this encryption or encrypted connectivity between these devices. So it is going to help our customers keep data sent over public networks. This is going to be providing secure network connectivity. So then it is going to be actually just set up as VPNs. So it is going to be working with encrypting the IP address and IP address packets along with authenticating the source where the packets are coming from. So most of the time when a customer is asking about verifying the source IP address, without IPsec or ExpressRoute, they can do route tables between application gateway and also Azure Firewall. And now Azure Firewall Premium is given there. You can even actually just like analyze it with Sentinel for the source IP address. But there's another way. You can do IPsec or ExpressRoute. So basically, the steps are like from the steps perspective, it is gonna be they can configure side-to-side VPN to the virtual network gateway or ExpressRoute private peering using an RFC 1918 IP address ranges. So this configuration is going to be providing them with the traffic or private IP is going to be encrypted. It's already encrypted on the Azure circuit ExpressRoute side. Now the traffic over private peering is going to be encrypted. So point-to-site users connecting to virtual network gateway can now use ExpressRoute via the site-to-site tunnel to access on-premises resources, which is going to be provided now with more granular security. So for traffic from on-premises networks to Azure, the Azure prefixes are now going to be advertised via both ExpressRoute private peering BGP and then a VPN BGP. There you go, double protection on that part. The result is going to be two network routes, which we call them paths, towards Azure from the on-premises networks, which is going to be giving the customer not only one path, but is going to give them the second one from the encryption point of view. They're easy. So then Azure Firewall. So how it is actually just like, extending Azure Firewall, extending the Microsoft security, and then how this actually is providing the centralized logging, and then built-in high availability and auto scalability, networking and application traffic filtering, and IDPS, which I mentioned. Then the forced tunneling side of it. So the client on the internet is going to forward the traffic to MVA on premises. So on the MVA, they will configure the route tables to forward the traffic to backend application in the spoke that they create through the Azure Firewall. So they're going to have the route table in the gateway subnet is going to be part of their standard design, and then they will be able to actually just like do the forced tunneling to on premises. So let's say that if they have the BGP. If they have the ExpressRoute, a BGP is going to be actually just leveraged to perform this forced tunneling. So customers will need to create a UDR and associate it to the subnet that needs to exclude the default route and override it. So basically, they will be able to actually just use it, and then they will be able to use the additional dedicated subnets like the Azure Firewall Management subnet, which is going to be required to actually just provide that kind of like a UDR to quad 0 to enable this forced tunneling, which is going to be one of the requirements of the customers. So then the Azure Firewall and Sentinel integration. This is the seamless integration of Azure Firewall and Azure Sentinel to enable our customers with the security operations, which are going to be focusing on monitoring and visualizing Azure Firewall activities, which I mentioned, like even the IDPS, detecting the threats and leveraging AI like assisted investigation capabilities, and also the automated response and correlation to all the resources which are actually just applied on the Azure portal. So basically the firewall workbook and Sentinel integration, this is gonna be very key for the overall deployment. Our customers can actually just go ahead and just like download the workbook from the GitHub, so that they can reach to the Azure Firewall data connector for Azure Sentinel, which they can actually just use to ingest all these logs to visualize the data in the firewall workbooks, which are available in the Sentinel. So I'm just gonna give some examples like, some of the built-in threat detection, for example. So all these logs of Azure Firewall can help identify patterns of any malicious activity and indicators of like compromise in the internal network. So basically, Sentinel is going to have this built-in analytic rules, and then these really will provide our customers with, very powerful, reliable method for doing all the analysis of the logs to detect the traffic representing indicators of compromise in their network, which we call them IOCs. So with added support for Azure Firewall to these detections, now they can easily detect malicious traffic patterns which are going to traverse through the Azure Firewall, in the network, which is going to allow them to rapidly respond and remediate the threats, which wasn't available before. It has been available. So So I'm gonna mention about this, like, rules, for example, built-in threat detection rules, and some of the technologies there, and some of the elements. So there are some types of detection rules. So let's say that, like, I'm gonna give an example from the port scan. Why this is important is because this is going to identify a source IP, which is going to be scanning multiple open ports on the Azure Firewall. Basically, this is a common thread. And then because why? The attackers, they actually incline to use malicious scanning, which is actually their weapon to reveal open ports in the target so that they can compromise the system for the initial access. This is what they are doing from the port scan perspective. There's also port sweeping detection rule. So what exactly it does is that it really is identifying the source IP, scanning the same open ports on the Azure Firewall, different IPs. It's very important. Just like the port scanning, an attacker this time intends to reveal that IPs with specific vulnerable ports, which they find open in the target, which is going to make it easier for them. So then there are two more rules, which are abnormal denial rate for source IP and abnormal port to protocol. So, like, let's say the attacker, he wants to, or she wants to aim potential exfiltration and initial access. So they are just going to try to exploit the same vulnerability on the VMs in the organization. They won't go elsewhere. And then they're going to be looking at the abnormal port to protocol, which is really, like, very easy for them because they know that, like, ports SSH or HTTPS, and then is going to be actually just vulnerable. They can go in and just do that. And then the last one is the multiple source affected by the same threat intelligence, which is important. This is the rule to actually catch many machines or multiple machines that are trying to reach out to the same destination. Let's say that there's an attack that are actually just sourced from multiple machines, that you can actually just create this rule. So then how are you going to be actually just, like, blocking it? You're going to be blocking it by the threat intelligence, which is in the Azure Firewall embedded now. So the reason why an attacker uses multiple machines is the question, because what they're trying to do is that they can regroup all these machines that they are actually using to create a specific group so that they can exfiltrate the data from that organization. So then the hunting queries come, right? So these are all the tools for the security researcher to look for threats in the network for any organization, either an after incident has occurred or potential to discover new or unknown attacks. This is the reason why I said Microsoft is going to build all these tools to actually just help our customers understand what these threats are. So to be able to do this, security researcher is going to look at several indicators of compromise, like IOCs that we call them. These are like, these are going to be like first time a source IP connect to a destination port, first time source IP connect to a destination, source IP abnormally connecting to multiple destinations, uncommon port for the organization, uncommon port for connection to the destination. Like, let's see that I'm just going to give you an example from uncommon port for the organization. So this is to find out abnormal ports used in the organization network. And then is going to be actually uncommon port. And then this is the area where an attacker can bypass monitor ports. So then they can send the data through the uncommon ports. These are all going to be embedded now in the Sentinel. So all the customer needs to do is to actually just leverage Azure Firewall and then use the data connector connected to the Sentinel. There you go. So we also just announced the availability of the custom logic app connector along with 3 new playbooks, templates for Azure Firewall. So this can be also just used with the Azure Sentinel automation feature and analytic rules. So they can actually just take a variety of desired actions in case of any detection. So then they can leverage the Azure Firewall connector. Then they can go from there. They can use the Azure Firewall block IP, add to IP groups, and then they can go from there. Basically, this playbook, especially the Azure Firewall block IP, add to IP group playbook, is really helping the customers to block IP addresses in the Azure Firewall by adding them to the IP groups based on the analyst decision. So how it is going to help them? It is going to help the customer to make these changes on these IP groups, which are going to be attached to the firewall rules instead of just making changes directly to the Azure Firewall. So then the target IP group is going to be associated with the policy rules, which are going to be used in one or more firewalls that they actually just create. So DDos implementation. I'm actually just going to go with a demo, and then this is going to be the end of it. And I hope that I have 4 more minutes, and I'm gonna be trying to use it as fast as I can. Why this is important, Holger, is because anything that I spoke about so far, Azure Firewall, Application Gateway, Sentinel, anything, integration, automated response, floods, UDP attacks, anything. Nothing is going to be protected inside the virtual network if you do not implement DDoS. The reason why I'm gonna say this, one of our customers, they reach out to me. They said, hey, we are using Azure, from Azure DDoS Basic. Are we good to go? Let's go in and just do some, testing. So I asked the customer to do the test. They did the test, and I helped them. I actually initiated the attacks. Then what happens is that the customer looked at me and said, I didn't know that we were actually just being hit like this. And I said, then they were saying that, hey, what is this going to take for me to actually just make sure that I can enable it? It was just click of a button. So basically, Azure DDoS combined with the application design best practices is going to help customers defend against DDoS. DDoS protection is going to provide them with a lot of benefits. What I'm gonna say, if they leverage Basic, they're free to go. They're free. It is free. It is free, but it's only just going to protect in the Azure services. It is going to protect Azure services. It's not going to protect their private network, which they create in Azure, which is going to be their VMs. So the basic service tier is automatically enabled as part of the Azure platform already. So then the question should be, what is the difference between the basic and then the standards, right? So the basic is going to include always on traffic monitoring, and then the real-time mitigation of the common network level attacks is going to provide the same, defenses that Microsoft Online Services uses. So the entire scale of the Azure Global Network is still going to be, used to distribute and mitigate attacks, traffic across regions. But when it comes to the SLA, it is not going to provide SLA. So the standard one is going to provide additional mitigation capabilities over the basic service that are actually tuned specifically to Azure Virtual Network resources that we talked about. DDoS standard is very simple. It is going to be enabled, and it is going to require nothing from the application changes perspective. You're just going to need to just enable that. So then the protection policies are going to be tuned through the dedicated traffic monitoring and machine learning algorithms. So then the policies are going to be applied to the public IP address associated to the resources deployed in the virtual network, such as Azure Load Balancer, Application Gateway, Service Fabric instances. But this protection doesn't apply to Azure App Service environment. So Azure Monitor views make real telemetry available during an attack for any history. So reach attack mitigation and analytics are going to be available via the diagnostic settings still, but you are still going to be able to actually just protect your resources. And then if you want to go ahead and just use the application layer protection through the Azure Application Gateway WAF functionality, you will be able to protecting that functionality by leveraging Azure DDoS standard. So the key is, why do I need to have WAF then? Yes, you need to have the WAF. Web Application Firewall is a header on the application gateway. But what Microsoft does, if you are going to be enabling Azure DDoS standard, you are still going to have WAF, but you won't pay for the WAF component. It is zero. This is 100% discounted. So then you won't necessarily worry about it. Then the monthly charge, it is going to be including protection for 100 public IP address resources, I don't know if I can actually give the audience the pricing. Am I allowed to give the pricing, Holger?
Sure. I mean, we can also link then.
We can link, but it is close to $3,000 for 100 IP, public IP resources. So there's going to be overcharge more than, like, if it is more than 100 public IP address resources, it is like $29 a month per additional IP address. So the network protection is going to be enabled at the virtual network level, which is the VNet. So all the protected resource types within that virtual network will be automatically protected when network protection is enabled on the virtual network gateway. So when Azure Application Gateway with WAF is deployed, again, this is very important, very exciting actually. If it is deployed in a protected virtual network, there are not going to be any additional charges for the WAF. Customer is only going to be paying for the application gateway at the lower non-WAF rate. Basically, they're going to be actually just getting the discount on the application gateway as well, zero WAF component. So if the resource is protected with the network protection, any scale out cost during that, like, DDoS attacks are covered. Basically, egress is going to be, now when I'm actually going to be showing you my demo environment, you are just going to see what I actually just do. Let me actually just go to my demo.
Yeah, let's go to the demo. Yeah.
This is going to actually just make it even easier. So what we are doing here is that, let me actually just get the slide again to show one more component, like for the for what exactly the demo is going to be about. So we are using Breakpoint Cloud to simulate attack on Azure Firewall today, and also application gateway. Why? DDoS is always going to target the public IP address, either application gateway or Azure Firewall. In this example, that I'm just going to be attacking the application gateway IP, which is going to be 13.89.108.163 application gateway public IP. I'll use application gateway public IP and then do the flood on this IP. So I'll choose port 443 and I'll choose DDoS profile TCP send flood and do 200K PPS at 100 megabyte per second, not bits, byte per second. And I'm going to use 8 source IPs. So a SIM flood, what exactly it is? So like the audience is going to say, what is SIM flood? What exactly it is? It is actually a denial of service attack in which an attacker rapidly, they go ahead and just initiate this connection to a server without finalizing the connection. They don't need to worry about it. So the server has to spend resources waiting for, half open connections, which can consume enough resource to make the system unresponsive to legitimate traffic. Somebody is just making the traffic request, it is going to be unresponsive. So then the SDP one, I'm actually not going to be showing it, but it's going to be attack. Basically, is another distributed denial of service attack. This time, it actually just like exploiting this universal plug and play, which we call them UP, lowercase np, networking protocol, so that it actually is sending huge amount of traffic to the target victim, which is going to be my application gateway. So with this, I am just going to show you what I got.
Okay.
Basically, while we were actually just like, doing this demo, like this presentation, what I did, I actually just started my test. My test started at my time today, 11:44.
Yeah.
It took 10 minutes and I did 8,056 MB data, which actually cost us a lot of money while we're doing it. So, I mean, my networking team is actually giving me a hard time. Toby, if you're listening to me, don't give me a hard time. So 109 megabit per second throughput, and then frame sent. This is, again, I use TCP send flood, which actually just gave me 200K PPS, and then 100 megabit per second at 8 source IP addresses. And then last run result is going to be 118,467,000 is actually frames sent. And then frames per second is 199,000. It's actually, 118,467,548.000. and then 199,475 frames per second. Let's say that you don't have the DDoS protection enabled on your system. Good luck.
Yeah.
But if you want to have DDoS protection, it is $2,900. It's close to $3,000. And then you actually just enable it. So once I actually just go to my subscription to see it in real time, you are just going to see when my attack started. So let me just select the metric here. Then you will see that it actually just started exactly at the time. And then it actually just took how long? So basically, all the customer needs to do here, Holger, is to go ahead and just change the basic SKU to standard SKU. And then this is just the one very simple, actually simple example of how brutal this attack can actually just be. So now, what is Microsoft going to guarantee from that perspective? Like, let me just go to my slide here to show trick to enable Azure DDoS standard and then reduce the cost. This is very simple argument, right? About how we can actually just do this simple and cheap. Here in this example, that customer needs to duplicate a backend application to a paired region. This is something. Number one, they're going to duplicate the application gateway without WAF in a new paired region for the new backend. Since we're going to be using DDoS, they're going to remove the WAF from the current application gateway. They're going to create the front door with the global WAF. They're going to use public IP address of each application gateway for front door backend. So they're going to purchase DDoS standard at, again, $3,000 a month. They're going to apply the DDoS standard to 2 VNets, one in each region for application gateway and backend servers. So what happens with this? They get regional redundancy. They get WAF for free. They get access to DDoS ARR support, which is $75,000 a year. And then since there's not going to be any kind of overhead on the application gateway, you're actually just like, loosening it. And then you don't need to use the second SKU for application gateway. Since you are using Azure DDoS standard, you're getting the application gateway at the lowest WAF rate. Then you are getting this kind of like an optimized solution from Azure. So basically, it is all about the design, it's all about what the customer really wants to do. And then they go ahead and just like, leverage it. Now, let's go and just see the Azure Firewall. They're going to say, hey, what if that I actually just throw a firewall? This is going to be expensive. So no, it's not going to be. It's actually going to be per deployment, regardless of the number of instances in a scale set. So this is going to be same for the standard or premium SKU. So when we are looking at the application gateway pricing, then you're really looking at the small, medium, and large type of Azure application gateway. So then you're going to get, like, let's say that you're going to get that large application gateway SKU, you're going to get the minimum ever. Basically, you're only just going to be paying for the amount of time that the gateway is provisioned and available, as well as the amount of data which is being processed by the application gateway and firewall. So if a customer requires WAF functionality for detection and prevention mode, they go ahead and just use Azure Application Gateway large type of version 2, and then they are just going to enable the Azure DDoS standard, and then this is going to be reducing, or not reducing, terminating cost for the application layer from the WAF point of view. The customer is not going to pay for the WAF anymore. So with this, I am just going to be actually just like, ending my presentation. But again, there are lots of great areas to mention. So basically, when a customer is looking at a design like this, they use the Azure front door and bot protection with Azure WAF and Azure DDoS. They get the rate limiting, managed WAF, IP geo restrictions, custom WAF rules, global anycast, free managed TLS, forced TLS, and then they're going to get minimum TLS version 1.2. And good news, application gateway right now is supporting version 1.3 as of today. With this, I am just going to provide the audience this presentation. And again, Holger, I'm so happy to be here. So thank you very much for giving me this awesome opportunity to be
No,
speaking
thank
in
you.
here.
Thank you, Evren. I think that was, I mean, it is again a little longer. I think we need to get used to that. If you are on the show, then the show is a little longer than typical. But I think it's, I mean, you showed so many really interesting things. And what I really liked is that you're not only talking about this, so you not only have the slides, but you really also have a demo to really showcase the scenario. So you have really implemented, and that's
for
something
the demo,
that I really
for the demo purposes, we are actually having limited access on that. If anybody wants me to go deeper into it, audience can reach out to me, and I can actually provide more insight into, because there are lots of threat vectors to use. So I'm so ready to share any documentation information if they reach out.
Perfect. Evren, thank you for being the first guest in 2023. I'm sure we'll see you again. Thanks so much for now. And yeah, security is a super important topic, and I think you provided a perfect foundation with lots and lots of content, and I'm sure the audience will really love it.
Thank you so much, Holger. Thank you very much.
You.
Wonderful day.
Bye-bye.